Hello again. Welcome back to Algebra 1 with Miss Betsy. I'm glad you're along for the ride. We're continuing our discussion of relations, functions, and graphs of linear equations. And in this video, we're going to be doing something that I think is a lot of fun. We're learning how to use the slope-intercept form of a linear equation. If you're tracking along with me, I'm using Algebra 1 for Christian Schools. It's published by Bob Jones University Press. I'm using the second edition. I am in section 6.6. It's entitled The Slope-Intercept Form of a Linear Equation. I'm on page 246. You don't have to use the same text. Using the slope-intercept form of a line is the same process, same procedure, same methodology, no matter what textbook you're using. So come along, join us for the ride. And our lame joke for today, I'm still in my piggy joke book. What did Professor Hogg see when she looked through her telescope? Well, what she saw was the Pig Dipper. And they've got a sketch here. It's really dumb looking. It's a big old fat pig on one toe holding a little dipper in her hands. So, moving right along, slope-intercept form of a linear equation. And what is really neat about writing a linear equation is that there are several different forms that you can use. Each have their own specific little purpose. That is, sometimes it's good to use a standard form of the equation of a line, sometimes a slope-intercept form, sometime a new one that you'll get next in one of the next videos, which is called the point-slope form of a line. But what you'll remember is that we had the standard form of the equation of a line. It was ax plus by is equal to c. And in this equation, a, b, and c can be any real number in the world. This is what we call the standard form of the equation of a line. What we're going to see today is what we call the slope-intercept form of a line. And this is a very valuable form of the equation, slope-intercept form. And in this case, all that we do is we take the equation and we solve for y. And the slope-intercept form of a line, which you must memorize, y is equal to mx plus b. And in this case, what we have here, the m represents the slope of the line, and b is the y-intercept, or it's actually the y-coordinate of the y-intercept. And why exactly is this form of the equation of a line so valuable? Well, it's so valuable because if you have the y-intercept of a line, you know exactly what one of your points is. Oh, it's so funny. Look at this. I have not labeled the lower axis on this first grid here. Let me go ahead and do that right quickly. -1, -2, -3, -4. The reason that a y-intercept is so valuable to have is if you already know that the y-intercept is going to intersect the y-axis somewhere. So if you have a y-intercept of 1, you have one point on the line, and then you can use what you know about the slope of a line to find a second point. And you very, very quickly are able to sketch the graph of the equation. You don't have to do any tedious calculations or come up with test points. So the very first thing that you want to do to be able to do is have an equation that's been given to you. It's been given to you in general form or standard form of the equation of a line, and it's going to ask you to write this equation in slope-intercept form. This is example 1, and I am on page 246. And this says, write 3x plus 2y equals 6 in slope-intercept form. And finally, identify M and B. Nothing difficult about this at all. What we have is, we know this is the equation of a straight line. It's 3x plus 2y is equal to 6. And that fits the form ax plus by is equal to c. So we know that as long as we have an equation that has an x and a y in it, they're both what we call first degree. They both have only an exponent of 1. We know we have an equation that we can show as the graph of a straight line on a Cartesian plane. First thing we want to do is write this equation in slope-intercept form. We do that by solving the equation for y. 3x plus 2y minus 3x is equal to a negative 3x plus 6. So it had to bleed over onto the paper here. Do you see what I did? 3x plus 2y is equal to 6. If we want to solve this equation for y, what do we have to do first? We subtract a 3x from both sides of the equation. And we're going to make sure that we put the right-hand side of the equation with the x term first and then the y value. Okay? So we now have 2y is equal to negative 3x plus 6. Now what do we need to do? We want to go ahead and divide both sides of the equation by 2. What do we have now? Well, we have y is equal to negative 3x plus 6 divided by 2. Now, is that really helpful to us? Well, not particularly at the moment. And I'm trying to see something here. Wanted to make sure that I copied my problem correctly, and I have. Right here we've solved for y, haven't we? But we want to solve for y and have that equation in the point, in the y-intercept form, right here, the slope-intercept form of the line. We want to be able to identify M and B. Do you remember what I just wrote? I said that our slope-intercept form of the line, y is equal to mx plus b. And we want to identify m because we want to be able to identify the slope, and we want to be able to identify the y-axis. So we don't want all of this broken, separated. We want to separate this into two pieces where we have the x term by itself and where we have our constant term by itself. Now remember, when you add or subtract fractions, you add and subtract the numerators as long as we have a common denominator. So this is actually can be written as y is equal to negative 3x divided by 2 plus 6 divided by 2. Make sure that you look at that and you understand how the fractions work. Now we have our form. Y is equal to negative 3 halves times x plus 3. This right here is our slope-intercept form of the line. My cat came in here to join me, and when I dropped the marker, he thought that was quite funny and decided he would play with it. Our problem also asks us to identify M and identify B. Right here, M, or the slope of the line, is negative 3 halves, and the y-intercept, or B, is 3. We've put the equation in slope-intercept form of a line, we've identified the slope, and we've identified the y-intercept. And that's all that they have asked us to do for the first example. So what are we going to do if we have a linear equation and we solve or we change that linear equation into slope-intercept form? Well, it tells you the first thing you do is you solve the equation for y. The second thing that you do is you make certain that you have the terms lined up on the right-hand side with the variable first, so that you have your variable term and then your constant term. And then you're able to very clearly identify the slope and the y-intercept. Now, we've done this. It would be very easy to identify the y-intercept, the fact that we have a negative slope, and draw the graph right here. But you know what? I'm not going to do that right now. I'm going to go ahead and move on to the second example so that you can track with me exactly in your book and see what we have. This was example 1. Let me move on to example 2. Example 2 says graph y is equal to 1/2 x plus 4. Now when we did this in the last section and we had instructions that said graph the equation, you would do your table, you'd have x and y's, you'd calculate 3 test points, then you would connect the dots and you would have your line already graphed. Well, what you have here is very easy. We know what the slope is. The slope of this line is 1/2. We know the y-intercept is the point 4. The y-coordinate is 4. So what are we going to do? We're going to identify right here on our graph our y-intercept. This is example 2. And then we're going to use what we know about slope to calculate or to plot a second point on the graph. So what is our slope? Slope is 1/2. And what is slope? Well, slope is the change in y divided by the change in x. You can think of it as the vertical change divided by the horizontal change. Another thing that you hear a lot that slope is rise over run. And rise over run is used constantly in carpentry, particularly when you're laying out stairs, or when you're working on the slope of a roof. The rise is the change up and down. How far does something travel in a vertical way for every particular amount of travel in a horizontal way? Stairs have a rise over run. Let's say that they're going to rise 2 units. They go up every 2 units every time they travel 2 units to the right. 2 units to the right. So the rise is 2, the run is 2. That gives you a slope of 1. You think, well, that doesn't make any sense. Well, sure it does. Look at that. You can connect a straight line over your stairs, and that's what you used to do. You get on a mattress or a board or a piece of cardboard or whatever and just slide right down your stairs. See, right there's a little bit of applied math, and y'all tell me, what in the world is algebra good for? So anyway, I digress. We know that we have a slope of 1/2. So what is that telling us? It's telling us that our vertical change is a positive 1. So we can begin here. We can move up 1 unit. That's our rise. What's our horizontal change? It's 2 units to the right because it's positive. So we go up 1 unit, over 2 units, and we can plot our second point, which is going to be 2, 5, 4, 0. And that's all that we need because we now have 2 points that we can connect together. Remember I told you in the last video, it's always best if you can extend your line enough so that it crosses both axes. I don't have enough space here. But you can still clearly see that I have a line that is sloping up to the right, so we have a positive slope, which stands to reason, of course, because it tells me here that my slope has to be positive, and my slope is 1/2. For every 1 unit of positive rise, I have 2 units of a positive run. Up 1 over 2, up 1 over 2. So you'll see at this point on the line right here should be up 1 over 2. And that's exactly what it is. So you can count out your slope from any 2 points on the line. That's all that's involved in plotting the graph of a line, or drawing the graph of a line when you have your equation in slope-intercept form. That's why it's so very, very valuable to you. So let's go ahead and do another example and see what we have. This is example 3 that we're going to do. And this tells us on page 248 to graph 2x plus y is equal to -3. 2x plus y is equal to -3. What's the very first thing you want to do? You want to put it in slope-intercept form. And if you will just go ahead for this section, and every time that you have to convert, you might just want to go y is equal to mx plus b. The more times you write it, you'll ingrain that in your memory, and you'll never forget what slope-intercept form is. So we have to solve for y. What problem do you see that you have here? Exactly. If you were listening to me, I said 2x plus 3y is equal to a -3. Okay. I didn't say 2x plus 3y. I said 2x plus y is equal to a -3. 2x plus y is equal to a -3. We want to solve for y. We're going to do that by subtracting 2x from both sides of the equation. 2x minus 2x plus y is equal to -2x minus 3. Y is equal to -2x minus 3. First, you solve this equation for y. We now have the slope-intercept form of the y, and you can see that our slope is a -2, and our y-intercept is a -3. What does this mean to us? Well, this means that y-intercept is a -3. 1, 2, 3. We can label this point. X is 0, y is -3. What do we know about our slope? Our slope is a -2, or -2 is the same as a -2 over 1. We have to remember that with the slope we have a rise over a run. We have our vertical change. What's our vertical change going up and down? It's a -2. So we're going to count 2 units down, 1, 2, a +1, 1 unit to the right. 2 units down, 1 unit to the right, gives us the location of our second point on the line, which is x is 1, y is a -5. Now, we have our 2 points. Take your straight edge and connect the dots. Don't go down into the graph of the next problem. Connect the dots, label the line with the original equation. And you see that I forgot to do this for example 2. Y 2x plus y is equal to a negative 3. Don't scribble out on your homework for me, erase it. I was going to write the slope-intercept form of the line. That's not what we want. We want to have the original equation of the line. So this first one up here that I did not label, I think, yes. Y is equal to 1/2 x plus 4. And I didn't even need to look it up because I could say, okay, the y-intercept was 4. It has a slope of 1/2. That's all that's involved in doing these graphs. See how much nicer it is, easier, it's fun compared to having to plot points. Let's see what we can do for our next graph here. I'm going to go ahead and do 2x plus 3y is equal to 6. Do we have this in point slope form? No. What do we have to do? You solve for y. We're going to subtract the 2x from both sides of the equation, 2x plus 6. Is it in point slope form yet? I'm sorry, is it in slope-intercept form yet? No, because we have to solve for 1y. So we're going to divide both sides of the equation by 3. So we have 2/3 x plus 6 over 3. Negative 2/3 is negative 2/3 x plus 2. We've now written the equation in the slope-intercept form of the line. You can go ahead and graph this immediately. Where's our slope-intercept? It's positive 2. So we have 0, positive 2. That's our y-intercept. What's our slope? It's a negative 2/3. Vertically, we're moving down 2 units. There's 1, 2. Horizontally, we're moving 3 units. 1, 2, 3. So location of our second point. We label our points 0, 2, and x is 3, y is 0. Now this is pretty nice because what we actually have done here, if you'll notice, is we have both the y-intercept and the x-intercept. Now there is no x-intercept form of the line. There's only the slope-intercept form of the line, but here this time when we counted out our slope, we did actually end up with identifying the x-intercept. Going to connect our dots. Don't forget to put your arrowheads. And we're going to label this with the original form of the line. 2x plus 3y is equal to 6. It's all that's involved in doing these problems. And I do want to go ahead and do one more special form over here in example number 4. So what would happen if we have this equation, graph y is equal to 2? Well, what it said is we want to be able to put this equation into slope-intercept form of the line. And how are we going to do this? Well, it's already solved for y, but what's our slope-intercept general form say? Well, it says that y is equal to mx plus b. And I don't see any x's in this equation, do you? There aren't any visible, so what does that tell you about the slope? It tells you that the slope is 0. And the y-intercept is 2. So our slope is 0, and the y-intercept is 2. And what did you learn in your last video? If a line has a slope of 0, you learned that that is a horizontal line. that passes through the y-intercept. So you just pick another point. You have your lines connected. Connect the dots. Label the line. And you are finished. X is 0, y is 2, x is 2, y is 2. I think you'll enjoy playing around with these. Once again, only one graph, only one line graphed per each little grid that you set up. Use your ruler, use your grid paper. Enjoy yourself doing these, and I'll see you next time.